Hello, everyone. In this lesson, we will dissect the core architectural components of Azure, specifically focusing on the hierarchy of resource groups. Understanding how resource groups fit into the broader Azure management structure is essential for organizing, securing, and deploying your cloud resources effectively. To understand where resource groups fit, we must first visualize the Azure management hierarchy. At the top, we have management groups, which allow you to manage access, policy, and compliance across multiple subscriptions. Below that are subscriptions, which serve as your billing and management boundaries. Directly beneath subscriptions sit the resource groups. A resource group is a container that holds related resources for an Azure solution. Finally, at the base, we have the individual resources themselves, such as virtual machines or storage accounts. This hierarchical structure ensures that settings applied at a higher level, like a subscription, can flow down to the resource groups and resources below. This flowchart illustrates the vertical hierarchy. At the top is the management group, which governs the subscription. The subscription contains the resource group, highlighted in orange. This resource group is the container that holds individual items like a resource, VM, resource, SQL-DB, and resource, VNet. This visualizes the parent-child relationship where the resource group sits between the subscription and the actual resources. A resource group is more than just a folder. It is a fundamental building block of Azure. It acts as a logical container for resources that you want to manage as a single entity. Key rules apply here. A resource group belongs to exactly one subscription, and crucially, you cannot nest resource groups inside one another. Furthermore, the resource group stores metadata about the resources. When you specify a location for the resource group, you are defining where that metadata is stored, which is critical for compliance and data residency requirements. Here we see a block diagram representing the containment structure. The outer block is the subscription. Inside it sits the resource group block. Inside that group, we see three distinct resources: a web app, a database, and a storage account. This visual reinforces that the resource group acts as a single boundary wrapper for multiple related services within a subscription. The primary purpose of the resource group hierarchy is lifecycle management. You should generally add resources that share the same lifecycle to the same resource group so you can easily deploy, update, and delete them as a group. For example, if you have a web application that relies on a database and a virtual network, putting them in the same group allows you to decommission the entire solution by simply deleting the resource group. This prevents orphaned resources from lingering in your subscription and accruing costs after the main application has been removed. Resource groups provide a vital layer for security governance through scope. Azure Role-Based Access Control, RBAC, allows you to assign permissions at different levels: management group, subscription, resource group, or resource. By assigning a role, such as contributor, at the resource group scope, you automatically grant that user control over every resource inside that group, but nowhere else in the subscription. This allows you to isolate workloads. One team can manage the dev resource group without having any access to the prod resource group, enforcing the principle of least privilege. This diagram shows a user and a subscription containing two resource groups: HR resources, green, and IT resources, red. The solid arrow indicates the user has contributor access specifically to the HR resources group. The dotted line to IT resources indicates no access. This visually demonstrates how the resource group hierarchy acts as a security boundary, allowing granular permission assignment. Beyond access control, the resource group hierarchy is essential for governance via Azure policy and tags. When you apply a policy to a resource group, such as enforcing a specific region for deployments, that policy is inherited by all resources created within that group. However, it is important to note a distinction. While permissions and policies inherit, tags do not automatically cascade from the group to the resources by default. You apply tags to the resource group to organize the container itself, helping clarify billing and ownership for the collection of resources. This class diagram compares attributes. The resource group class has policy, RBAC, and tags defined. The arrow points to the resource class, which shows it inherits policy and inherits RBAC from the parent. However, it explicitly notes does not inherit tags. This highlights the specific behavior of the hierarchy regarding different governance metadata. A common misconception about the hierarchy is location dependency. When you create a resource group, you must provide a location, like West US. This location is strictly where the resource group's metadata is stored. However, the resources inside that hierarchy are not bound to that location. You can have a resource group in West US that contains a virtual machine in East US and a storage account in North Europe. This decoupling allows for flexible architectures, though you should be aware that if the group's region is down, you may not be able to manage the group metadata, even if the resources themselves are running fine. This diagram separates logical containment from physical location. The resource group metadata is stored in region A. It contains resource 1, which is deployed to region B, and resource 2, which is deployed to region C. The dotted lines represent the logical hierarchy, containment, while the solid arrows show the distinct physical locations, proving they operate independently. To summarize, the hierarchy of resource groups is the skeleton of your Azure environment. It sits between subscriptions and resources, providing the essential structure needed for lifecycle management. By using this hierarchy effectively, you can deploy solutions as a unit, secure workloads through scoped access control, and enforce compliance via policies. Whether you are organizing for billing, security, or deployment, mastering the resource group hierarchy is the first step toward a well-architected Azure estate. Our final mind map centers on the Azure hierarchy. It branches into 4 key benefits. Governance covers policy inheritance and RBAC scope. Lifecycle includes unified deployment and group deletion. Organization highlights metadata containment and billing aggregation. Finally, structure confirms its place, child of subscription and parent of resources.